12th of January 2006, Chilbolton Observatory, the United Kingdom. This large antenna is receiving signals transmitted by GOVA, the first Galileo satellite. It's a historic moment. Galileo signals are passing through space for the very first time. Galileo is now becoming a reality, and the European Space Agency has begun the construction of a civil system with a global purpose. But Galileo must proceed in stages. First, the new technology must be tested. This is the aim of the current phase. With GOVA, for example, accurate atomic clocks and an innovative signal generator are being put through their paces. It's possible to calibrate not only the signals emitted in orbit, but also the instruments responsible for receiving them on the ground. In fact, to test out the entire system. After this essential testing phase will come the real transition from theory to practice with the launch of 4 satellites, the basic formation underlying satellite navigation. Briefly, the satellites are clocks continuously telling the time. The signal sends the time to the ground, where receivers measure how long these signals take to reach them, and from this, calculate the distance between the satellite and the receiver. The exact position is obtained by triangulation with the satellites as reference points. At least 4 satellites visible to the receiver are needed to obtain the best information regarding position, time, and speed. The more satellites there are, the more accurate the results. Hence the planned future development of a constellation of 30 satellites at an altitude of around 23,000 kilometers, linked to ground stations to create a veritable global network. Then Galileo will be able to provide in full its many applications on and around the Earth, from the simplest, finding your way, to the most complex. On the road, for example, Galileo will be able to recommend the best route to avoid traffic jams and will monitor frequency of use on our road networks. It will offer ways of managing fleets of taxis and lorries. For air transport, it will provide additional safety, particularly during the tricky landing phase. These satellites will become our new stars, keeping watch over river traffic, ships in port and out at sea. Galileo will improve search and rescue operations. An injured person will be able to send a distress signal giving his precise position. The network will be able to register the SOS message and be able to dispatch assistance to the site of the accident, thus saving vital time. Countless uses in our working lives will be developed from this space technology. A vast range of applications in every area imaginable. Applications that will revolutionize our daily lives. This joint initiative of the European Commission and the European Space Agency will equip Europe with a system capable of providing guidance and assistance no matter where. And the advantage of Galileo is that it's a civil system, thus guaranteeing continuity of access and signal quality, unlike the American GPS system, which is under military control. Nevertheless, Galileo and GPS will be compatible and interoperable, increasing the reliability of both systems and making their use safer. While waiting for Galileo to become fully operational, Europe already has a positioning system in place, EGNOS. This is a network of ground stations which act as a GPS signal filter, improving and retransmitting these signals via geostationary satellites. It's accurate to within 2 meters, compared with the 15 to 20 meters offered by the current GPS system. EGNOS is accessible to all. Originally designed to improve air traffic safety, it is now preparing the way for Galileo. These are the foundations of satellite navigation in Europe. The launch from Baikonur of GOVA on the 28th of December 2005 was the first building block of the Galileo system that will allow Europe to establish its political and industrial independence in the field of satellite positioning and localization.